Hi, I'm Mina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
TTS, the Deep Dive Episode 2026, SU 504.
Imagine dropping a glass on your kitchen floor, and just for, a microscopic fraction of a second, the universe just completely forgets which way time is supposed to flow.
Right, like reality just skips a beat.
Exactly. The shards don't, physically jump back into your hand or anything, but at the quantum level, the absolute rule of cause and effect simply blurs.
It's a fascinating concept.
It really is.
Yeah.
Today, we are looking at a massive stack of research, all from early May 2026, that proves reality is actively breaking its own rules right now.
Yeah, from physics to geopolitics, the structures we rely on are fundamentally shifting.
They are. So welcome to the Deep Dive. We have an incredible journey ahead of us today, piecing together information from global news outlets, scientific journals, and archaeological dispatches.
With a lot of ground to cover.
It is, but the goal is to understand how humanity is navigating a world that is essentially rewriting itself. So are you ready to get into this?
I am. The sheer volume of incoming data right now is staggering. But when you lay it all out on the table, a very clear narrative emerges.
Which is what, exactly?
Well, we are a species desperately trying to map the unseen. I mean, whether we are using artificial intelligence to find invisible planets or tracking the hidden fluctuations inside a simple glass of water.
Or even trying to anticipate the unseen tectonic pressures building beneath the North American coastline, right?
Precisely. Humanity is actively pushing against the absolute edges of what we can perceive.
Okay, so before we can look at the physical planet or the geopolitics of it all, I feel like we have to start at the absolute foundation.
The physics.
Yeah, we have to talk about physics. Specifically, a discovery that challenges the one thing we all take for granted, which is the forward march of time.
This was a huge paper.
Right. A recent paper is suggesting a tiny flaw in time at the quantum level, introducing this concept of negative time.
Yeah.
Now, I look at that phrase, and I gotta be honest, it sounds like a bad science fiction trope designed to explain away a plot hole in a movie.
Huh. I can see why you'd say that.
So, I mean, is this just a mathematical trick, or are particles actually experiencing reversed causality?
It is a profound disruption of how we understand thermodynamics. So let's separate your kitchen floor from the quantum realm for a second.
Okay, fair enough.
At the macroscopic level, the dropped glass you mentioned earlier, the arrow of time, is dictated by entropy. Things move from order to disorder.
Right. Gravity pulls it down, it shatters, it doesn't unshatter.
Exactly. That arrow is absolute for us. But zoom in to a single subatomic particle within that glass. The equations of quantum mechanics, like the famous Schrödinger equation, are largely time-symmetric.
Meaning what? They work backwards.
Yeah, they do not care if time flows forward or backward. The math works either way. What this new research suggests is that during a quantum event, specifically something called wave function collapse, where a particle goes from a probability cloud to a definite state because it's being measured, the temporal measurement doesn't just proceed linearly.
Wait. So the actual act of measuring the particle is what breaks the clock?
In a way, yes. The research indicates that the strict timeline of cause-preceding effect becomes statistically fuzzy.
Fuzzy. That's a comforting word for the fabric of reality.
I know, right? But the particle might experience a sequence of states that, mathematically and observationally, look like time is flowing in reverse for a microscopic fraction of an instant before finally resolving.
So it's not that the shard of glass literally jumps back up off the floor.
No, not at all.
Yeah.
It's that the subatomic foundational blocks of that glass are occasionally oscillating backward and forward in time during state changes.
That is just wild.
And it's critical, too, because it potentially provides the missing mathematical link between the smooth, predictable geometry of gravity, general relativity, and the chaotic, probabilistic world of quantum mechanics.
Okay, so gravity might actually be interacting with these microscopic temporal fluctuations.
That is the implication.
That is deeply unsettling, honestly. It means the foundation of reality is constantly flickering. And speaking of things flickering right under our noses, we have a March 2026 study published in the journal Science.
Oh, the water study.
Yeah, they used ultra-fast lasers to probe water. And they discovered that liquid water is actually hiding a dual nature.
Water is arguably the strangest chemical compound in the universe.
Really? Because I feel like we take it for granted since it covers the whole planet.
We completely take it for granted, but it constantly breaks the rules.
Yeah.
I mean, for almost every other known substance, the solid form is denser than the liquid form.
Oh, right. Like if you freeze liquid iron, the solid iron sinks.
Exactly. But ice floats. Water also has an extraordinarily high specific heat capacity, meaning it absorbs vast amounts of thermal energy before its temperature actually rises.
Which is why our oceans don't just boil away in the summer.
It's precisely. That anomaly is the only reason our oceans can regulate the global climate. Now, scientists have long known this weirdness comes down to hydrogen bonds.
That's the way the oxygen atom of one water molecule attracts the hydrogen atoms of another one, yeah.
Right. But knowing it's about hydrogen bonds isn't the same as actually seeing it happen in real time.
So how did these lasers change the picture? What did they do?
Well, the researchers probed supercooled water.
Supercooled meaning below freezing.
Yes, cools well below its freezing point, but kept in a pure enough state, meaning without impurities to form ice crystals around, so it actually remains liquid.
Wow.
And by hitting it with femtosecond laser pulses,
Wait, what's a femtosecond?
makes a flash of light that lasts a quadrillionth of a second.
Oh, jeez. That's fast.
Very fast. By using those, they were able to capture the molecular arrangement in real time. And they discovered that water doesn't just sit as one uniform liquid.
What does it do?
It rapidly transitions between two distinct liquid states, a high-density liquid, or HDL, and a low-density liquid, or LDL.
Okay, hold on. So if I'm looking at my glass of ice water on the desk right now, you're telling me the liquid inside is secretly fluctuating between two completely different physical structures.
That is the reality. The low-density state resembles the open, bulky tetrahedral lattice of ice. The molecules are basically holding each other at arm's length.
Okay, and the high-density state.
Simultaneously, the high-density state is collapsed, it's jumbled, and much more compact. The water is constantly rapidly oscillating between these two arrangements at the molecular level.
Okay, but what does that actually mean for us practically? I mean, is this just a triumph of observation, or does it change how we interact with the physical world?
Oh, it changes everything from industrial chemistry to our survival as a species.
Really? How so?
Well, water is the universal solvent. If we understand the precise thermodynamic triggers that cause water to shift between the high-density and low-density states, we can engineer vastly more efficient chemical manufacturing processes.
Oh, I see.
But the much broader implication is climate modeling.
How does molecular water affect the global climate models?
As the oceans absorb heat, their thermal expansion is directly tied to these shifting molecular structures. If our global climate models are based on an oversimplified understanding of water's thermal dynamics, our predictions for sea level rise and ocean current disruption might be missing a massive variable.
So we might be underestimating how the oceans act when they warm up?
Exactly.
That's incredible. So we are using lasers to see the invisible structures in a drop of water on Earth, but we are also using incredible new tools to see the invisible structures of the cosmos.
Yes, the scale shift is amazing.
It really is. Our next set of reports pulls us out into space, and it looks like artificial intelligence is completely taking the reins here.
It's becoming indispensable.
So NASA, the National Aeronautics and Space Administration in the United States, has this satellite called TESS.
Right, the Transiting Exoplanet Survey Satellite.
Yeah, and it basically stares at stars waiting for a tiny dip in light that implies a planet just passed in front of it. But the data analysis is now being handled by a new AI tool.
They named it RAVEN, which stands for Ranking and Validation of Exoplanets.
I love how NASA always forces a cool acronym.
Oh, they are the masters of the acronym. But the volume of data that TESS generates is simply beyond human capacity to manually sift through with any speed.
I can imagine. Just millions of stars.
Exactly. But RAVEN is uniquely capable of filtering through millions of light curves, and it can ignore the noise of stellar flares or instrument glitches, specifically to find planets with extreme characteristics.
And it actually worked, right?
It did. It just confirmed over 100 exoplanets, including 31 entirely new ones. And a lot of them are largely in what astronomers call the Neptunian desert.
The Neptunian desert. That's a specific zone around a star, right?
Yes. When we look at planets that orbit very close to their host stars' orbits that take only a few days or even less, we tend to find two things.
Which are?
We find small, dense, rocky planets, similar to a really massive Earth. Or we find hot Jupiters, which are massive gas giants. What we historically do not find are planets the size of Neptune.
Hence the desert.
Exactly. That orbital region is just stripped bare of them.
why is that, though? Like, what happens to a Neptune-sized planet if it gets too close to its sun?
The intense stellar radiation essentially boils the planet alive. A Neptune-mass planet just doesn't have the immense gravitational pull of a Jupiter to hold on to its atmosphere under that kind of thermal assault.
So the atmosphere just cooks off.
Yeah, it gets stripped away into space, leaving behind only the rocky core, which then just registers to our telescopes as a large rocky exoplanet.
Ah, so it was a Neptune, but it got downgraded.
Precisely. But Raven is finding planets that defy this model entirely. It's finding intact, Neptune-sized worlds and ultra-short period planets that orbit their stars in less than 24 hours.
Less than a day to go around a whole star. That is dizzying. What does finding them actually mean for astronomy?
Well, finding these worlds forces us to fundamentally rethink planetary formation and migration. It suggests these planets might have formed much further out and rapidly migrated inward recently, or maybe they possess some unknown atmospheric shielding mechanism we just don't understand yet.
So it's rewriting the life cycle of planets.
It is.
And another report shows we are rewriting the life cycle of stars, too. So the XRISM space mission.
The X-ray imaging and spectroscopy mission.
Right, which is a collaboration involving the Japanese Space Agency and NASA. They have finally solved a 50-year-old mystery surrounding a star called Gamma Cassiopeiae.
This is a wild story. So Gamma Cassiopeiae is incredibly bright, and for half a century it has completely baffled astronomers because it emits these intense, fluctuating bursts of X-ray radiation.
And standard models couldn't explain why a star would do that, right?
No. Standard stellar models had no explanation for it. But XRISM's high-resolution spectroscopy peered through the glare and revealed that the X-rays aren't actually coming from the star itself. They are coming from a hidden companion.
Oh, wow.
Yeah, Gamma Cassiopeiae has a white dwarf orbiting it.
There's dead star.
A stellar corpse. A white dwarf is the extremely dense core left behind when a star like our sun exhausts all its fuel. But this specific white dwarf is close enough to Gamma Cassiopeiae that its immense gravity is actively cannibalizing the larger living star.
Cannibalizing it. That is a dark mental image.
It really is. It is siphoning off a stream of hydrogen and helium gas, and as this material falls toward the white dwarf, it forms an accretion disk.
Like a whirlpool of gas.
Exactly. It's spinning faster and heating up to millions of degrees, which is what produces the intense X-ray flares we've been detecting here on Earth for 50 years.
That is just a violent parasitic end to a solar system.
It is the brutal reality of orbital mechanics.
But contrast that with another discovery reported this week. Astronomers looking deep into the early universe have discovered that the very first galaxies were basically highly efficient star-making factories.
Yeah, they were consuming vast reservoirs of primordial gas at unprecedented rates.
So we have star factories on one end and cannibal dead stars on the other.
It provides a complete picture of cosmic ecology. In the early universe, billions of years ago, galaxies were incredibly dense with pristine hydrogen. They were ravenous, churning out massive stars at a rate that just dwarfs our modern Milky Way.
Just a boom time for the universe.
Exactly. But as the universe expanded and aged, that gas was depleted. Now, in our modern cosmic neighborhood, we see the late stages of that ecology. We see white dwarfs surviving by draining the outer layers of their companions just to stay active.
It's incredible to think about the universe having an ecology like that, and we don't even have to look light years away to find things that shock us.
No, we don't.
Right in our own cosmic backyard, on the fringes of our solar system out past Pluto, astronomers have potentially detected an atmosphere around a tiny icy world in the Kuiper belt.
This is one of my favorite recent finds.
Now, my understanding of the Kuiper belt is that it is essentially a frozen graveyard. I mean, it is near absolute zero out there. How on earth does a tiny ball of ice hold onto an atmosphere? Wouldn't any gas just freeze and fall to the ground as snow?
You are entirely correct regarding the thermodynamics, which is exactly why this discovery is so paradigm shifting. If there is an atmosphere there, it cannot be a remnant from its formation. It has to be actively replenished.
Meaning the planet is doing something right now to make that gas?
Yes. This implies outgassing. The working theory is that despite the freezing surface temperatures, the interior of this icy world is actually active.
How does it stay warm inside?
This could be due to radiogenic heating. Basically, the decay of radioactive isotopes like uranium and thorium deep down in its rocky core, providing enough warmth to melt the subsurface ocean.
Or It could be driven by a highly elliptical orbit that occasionally brings it just close enough to the sun to sublimate surface ices like nitrogen or methane directly into gas.
Regardless of how it's happening, it means the outer solar system isn't dead.
No, it is geologically and chemically very much alive.
But, as we reach further out to understand these distant worlds, there is a distinct, I guess I'd call it a technological mortality to our efforts.
That's a good way to put it.
NASA recently announced they had to shut down a 49-year-old plasma wave instrument on Voyager 1. This is a probe which launched back in 1977, and they shut it down just to save power.
Voyager 1 is currently out in interstellar space.
Right. It's moving further away from Earth than anything humans have ever built. And shutting down that instrument, it just feels like a stranded explorer slowly turning off their flashlight to save the last drop of battery for a radio beacon. It's incredibly poignant.
It really is a profound engineering twilight. So Voyager 1 operates on a radioisotope thermoelectric generator, an RTG.
Which is nuclear power, essentially.
Yes. It uses the heat from decaying plutonium to generate electricity.
Okay.
But that power supply decays a little bit every single year. The spacecraft is currently operating on a fraction of the power of a standard light bulb.
Just a light bulb out in the dark.
Yeah. So the engineers on Earth are performing this delicate triage across billions of miles of space. They are shutting down scientific instruments one by one so the core computer systems and the heaters stay warm enough to keep the transmitter whispering data back to us for just a few more years.
Man, that is bittersweet. But while Voyager, the great pioneer of that Apollo-era ethos, is slowly fading into the dark, we have the modern era roaring to life back here.
A very different vibe right now.
Totally. The Artemis II crew and NASA astronauts Christina Koch, Victor Glover, Reed Wiseman, and the Canadian Space Agency's Jeremy Hansen, they just successfully returned from their 10-day lunar flyby.
A massive success.
And to celebrate, they didn't just have a parade. They rang the NASDAQ closing bell in New York City, in the United States.
That image perfectly encapsulates the paradigm shift happening in space right now. Artemis III is set to land humans on the moon in 2027, and Artemis IV will follow in 2028 to assemble the Lunar Gateway space station.
But ringing a stock exchange bell, that's not just a publicity stunt, is it?
Not at all. It signals that space exploration is no longer solely the domain of government scientific curiosity. It is now a booming commercial and international ecosystem. Private enterprise, venture capital, and massive supply chains are driving the return to the moon.
So space is officially an economic domain now.
Without a doubt.
And that economic reality of space brings us to the physical economic realities right here on Earth, because technology isn't just about discovering exoplanets anymore, is it?
No, it's about power, infrastructure, and global geopolitics.
Exactly. Let's look at the new materials being developed. We have a report on a new material designed for radiation shielding in space, and it is thinner than a human hair and stretchy like rubber.
This is a game changer. Traditional radiation shielding relies on sheer mass thinking thick blocks of lead or massive water tanks.
Which is heavy.
And in space travel, mass is the ultimate enemy. Every extra gram costs thousands of dollars in rocket fuel just to escape Earth's gravity.
So a thin, stretchy shield?
It fundamentally changes the economics of long-duration spaceflight. It allows us to protect sensitive electronics and human DNA without the crippling weight penalty.
Incredible. We also have major leaps in sensor technology down here. A company called Ouster just released a new color Lidar system.
Right. Lidar is huge for autonomous tech.
Yeah, and for those who might not be deep into it, Lidar uses lasers to create high-resolution 3D maps of the environment. But historically, it's been colorblind.
Exactly. It knows exactly where an object is, but not what it looks like.
Right, so autonomous vehicles have always had to pair Lidar with standard optical cameras, which struggle in rain, fog, or like glaring sunlight.
Right, they get blinded.
Yeah.
But the fusion of high-resolution optical imagery directly into the depth perception point cloud of the Lidar sensor is a massive leap for autonomous navigation.
How does it make it better?
It means the vehicle's brain doesn't have to spend precious milliseconds cross-referencing a 2D camera image with a 3D laser map. It gets a unified, perfect understanding of the road in front of it, regardless of the weather.
That is going to save lives.
Absolutely.
And backing up all these sensors is a breakthrough from MIT, the Massachusetts Institute of Technology in the United States. Scientists there have mapped the 3D hidden nanoscale structure of materials used in ultrasound machines and naval sonar.
Yes. Relaxar ferroelectrics rely on the piezoelectric effect. They change shape when an electric current is applied, emitting sound waves, and they generate an electric current when a sound wave hits them.
Like a microphone and a speaker all in one.
Exactly. But for decades, the internal structure that allowed them to be so incredibly sensitive was a complete mystery. By mapping the nanoscale domains, the tiny regions where the electrical polarization aligns, we can now actually engineer these materials rather than just mixing them and hoping for the best.
So we can build sonar arrays and medical imaging devices that are exponentially more precise.
Yes, the resolution will be unprecedented.
But, stretchy radiation shields, color lidar, advanced sonar,
Yeah.
that's all just the hardware. The real technological arms race right now is the artificial intelligence infrastructure required to process all the data these sensors collect.
The AI boom is consuming everything.
It really is. The Pentagon just finalized agreements with 7 top AI companies, including giants like NVIDIA, Microsoft, and Amazon, for classified military operations.
Huge contracts.
But notably, Anthropic was excluded from the deal. And simultaneously, Co2 Management, a massive investment firm, formed a venture called Next Frontier to buy hundreds of acres of land in Indiana in the United States to build massive AI data centers specifically catering to Anthropic.
Yes, this ties into Amazon's $11 billion Project Rainier.
We are seeing a massive physical land grab right now.
We often talk about AI as if it exists in a digital cloud, like it's just floating around in the ether.
Right, out of sight, out of mind.
But AI is intensely physical. Training a large language model requires gigawatts of electricity and millions of gallons of water for cooling. It requires massive warehouse-sized buildings packed with thousands of specialized graphical processing units, or GPUs.
So private equity firms buying up farmland in Indiana, they aren't investing in software.
No, they are building the industrial factories of the 21st century. They're securing direct access to the local power grid.
Okay, but why the split? Why the split between the military contracts and the private sector land grabs?
Well, from a defense perspective, the Pentagon recognizes that AI is the ultimate strategic advantage right now. It dictates the future of logistics, battlefield surveillance, drone swarms, cyber warfare.
Basically everything.
Everything. They need to integrate this technology immediately, which is why they are locking in contracts with established hardware and cloud infrastructure giants like Microsoft and Amazon, companies that already have the security clearances and physical survey infrastructure to handle highly classified data.
Okay, so why exclude Anthropic?
The exclusion of Anthropic might simply come down to them not having that requisite cleared infrastructure yet. Or it could be due to differing corporate policies on lethal military applications. But the dual track we are seeing is very clear.
Which is?
The national security apparatus is militarizing AI software, while the financial sector is scrambling to build the physical power plants and data centers required to run it.
And building that infrastructure, shipping the GPUs, securing the rare earth metals, powering the data centers, that relies entirely on global trade.
It does. It's an incredibly fragile web.
Which brings us to the highly complex and currently very tense world of global geopolitics. Now, I want to be clear here. We are just looking at the reporting from all sides on this. No endorsements, just laying out the maneuvers.
Right, just analyzing the chessboard.
Exactly. So in recent actions, U.S. President Donald Trump announced a 25% tariff on cars imported from the European Union. This is an increase from the previous 15%.
A significant jump.
It is. The stated rationale from the U.S. administration is non-compliance by the EU with a previously agreed-upon trade deal. They are framing the tariffs as necessary to protect domestic American automotive manufacturing.
Right.
And at the same time, the administration expanded economic sanctions on Cuba, specifically targeting foreign banks and businesses that engage in commerce with the island, which increases the economic pressure on the Cuban government.
Trade tariffs and sanctions are the primary economic levers of geopolitics today. From a right-leaning or nationalist economic perspective, these moves are viewed as essential tools.
Essential for what?
To enforce international agreements, to protect domestic jobs in places like Michigan or Ohio from being undercut by foreign subsidies, and to exert maximum leverage against adversaries to force political reform.
But the international reaction, as reported, is starkly different.
Indeed. From the perspective of the European Union and from a more left-leaning free trade economic standpoint, these unilateral tariffs are viewed as destabilizing.
They see it as breaking the rules.
Yes. The EU sees this as a breach of international trade norms that harms global supply chains. They argue that a trade war ultimately raises prices for consumers on both sides of the Atlantic.
And on the Cuba sanctions.
Similarly, the expanded sanctions on Cuba face international criticism for exacerbating humanitarian issues without achieving the intended regime change. It's a deeply contested strategy.
But, the tension over tariffs pales in comparison to the physical security of global trade routes.
The situation in the Middle East right now is incredibly volatile.
Extremely. Specifically in the Strait of Hormuz, the U.S. warned international shipping companies against paying any tolls or quote-unquote donations to Iran for safe passage through the strait.
A direct challenge to territorial claims.
Yes, and following ignored warnings regarding these maritime boundaries, Iranian forces hit a U.S. Navy patrol boat with missiles.
Which is a major escalation.
Absolutely. Amidst this escalation, as a confidence-building measure, the U.S. evacuated the crew of a seized Iranian ship to Pakistan. Now, Iran has publicly offered to reopen safe shipping in Hormuz, but strictly on the condition that the U.S. lifts its economic blockade, explicitly deferring any talks about their nuclear program for a later date.
They are using the Strait as leverage.
And as a direct, immediate result of this conflict, global oil prices have jumped significantly.
Because the Strait of Hormuz is arguably the single most critical geographic choke point on the planet.
Explain the geography there for people who might not know.
It is a narrow waterway separating the Persian Gulf from the Gulf of Oman, and roughly 20% of the world's total global oil supply, along with massive quantities of liquefied natural gas, passes through it daily.
You can't just sail around it.
Exactly. It is the only exit. The U.S. perspective here is rooted in freedom of navigation. The U.S. military views protecting this waterway from Iranian control or extortion as a fundamental global security obligation. They argue it's necessary to prevent a hostile power from holding the global economy hostage.
And the Iranian perspective.
Conversely, Iran views the heavy U.S. military presence and the economic blockade as an existential threat to its sovereignty and its own economy. By threatening shipping and engaging U.S. vessels, Iran is utilizing its geographic advantage to create immense economic pain for the West, attempting to force the lifting of sanctions without conceding their nuclear ambitions.
And the economic pain is immediate, like we saw with the oil prices. When oil prices jump, transportation costs rise globally.
Everything gets more expensive.
Right. It impacts the cost of shipping those Lidar sensors from factories. It impacts the cost of running the supply chains to build those massive AI data centers in Indiana we just talked about. It drives inflation across the board.
It's all connected.
A geopolitical chess move in a narrow waterway in the Middle East directly ripples out to affect the funding and deployment of the very space exploration and technology we were just discussing.
It's a closed system. The vast technological ambitions of humanity are entirely tethered to the physical logistics and political stability of our home planet.
And while modern nations fight over trade routes, tariffs, and resources, a look back in time reveals this is an incredibly old human story.
We've been doing this for a long time.
We really have. Our ancestors navigated these exact same pressures of global trade, wealth storage, and survival. Let's unearth the past for a minute, starting with the story of pure chance.
The metal detecting finds.
Yeah. In Kutna Hora, which is a town in Czechia, a woman was taking a casual walk in a freshly plowed field when she discovered over 2,000 medieval silver denarii coins.
That is just incredible luck.
Imagine just walking your dog and stumbling across a literal treasure hoard. The coins date back 900 years to the 11th and 12th century, during the Permislid dynasty.
Finding a hoard of that magnitude intact is an archaeologist's dream.
What does a find like that actually tell us, though?
Well, these denaries were the lifeblood of the medieval Central European economy. Kutna Hora later became famous for its massive silver mines, but these kinds show the wealth flowing through the region even before those mines reached their absolute peak.
So someone was very wealthy.
Yes. But a hoard like this usually indicates times of severe instability. Someone buried their life savings to protect it from an invading army or political upheaval, and for whatever reason, they never returned to claim it.
So it's a time capsule of anxiety and wealth.
Exactly.
But to see how truly vast and interconnected the ancient world was, we have another major discovery. In Esterdalen, a valley region in Norway, amateur metal detectorists uncovered a massive hoard of 3,000 Viking-era silver coins.
Oh, they're a massive haul.
But the truly fascinating part isn't that they found Viking treasure in Norway. I mean, you'd expect that. It's the composition of the hoard. It included Arabic dirhams.
This is a perfect illustration of early globalization. We often picture Vikings strictly as coastal raiders.
Yeah.
Guys with axes attacking monasteries.
Right, that's the stereotype.
but they were, fundamentally, one of the most prolific and expansive trading corporations in medieval history. The presence of Arabic dirhams in Norway tracks the massive eastern trade routes.
How does an Arabic coin get all the way from the Middle East to a frozen field in Norway?
It was the Varangians, the Swedish Vikings. They navigated the massive river systems of Eastern Europe, like the Volga and the Dramper.
Oh, they sailed down through the continent.
Right. They sailed down into the Black Sea and the Caspian Sea, making direct contact with the Byzantine Empire in Constantinople and the Abbasid Caliphate in Baghdad.
That is a massive journey. What were they trading?
They traded furs, amber, and tragically enslaved people in exchange for high-quality silver dirhams. During the 9th and 10th centuries, there was a massive influx of Islamic silver into Scandinavia, because the dirham was essentially the global reserve currency of its day.
Like the US dollar today.
Exactly. It was universally trusted for its weight and purity. Finding it in Esterdalen shows that a local Norwegian chieftain or merchant was intimately connected to the economic output of the Middle East. The desire for trade has always bridged vast geographic and cultural divides.
So they were trying to master global economics, but they were also trying to understand the natural world.
Humans have always tried to model nature.
Yeah. Students at the University of Melbourne in Australia recently restored an 18th century mechanical volcano.
I saw pictures of this. It's amazing.
It was originally designed by Sir William Hamilton back in 1775 to simulate the eruption of Mount Vesuvius in Italy. The students used modern electronics and LEDs to bring the mechanical gears back to life.
It's a brilliant piece of historical engineering. Sir William Hamilton was a British diplomat in Naples, and he was absolutely obsessed with Vesuvius.
Why build a mechanical one, though?
This mechanical volcano represents the Enlightenment era mindset. Nature is terrifying. Clockwork to simulate lava flows and ash clouds, humans were attempting to demystify that power.
Ah, if you can build it, you can understand it.
Precisely. It was an attempt to capture, miniaturize, and intellectually control the chaotic forces of geology.
But sometimes the chaotic forces shaping humanity aren't giant, spectacular volcanoes. Sometimes they're entirely invisible.
The biology side of history.
Exactly. New evolutionary research shows that malaria didn't just kill early humans. It actively shaped human evolution and dictated migration patterns across the African continent.
We largely study history through the lens of human agency, the empires we build, the trade routes we establish. But this research highlights that microscopic pathogens have been just as influential in shaping human destiny.
Malaria specifically.
Yes, malaria, which is caused by the Plasmodium parasite transmitted by mosquitoes, exerted immense evolutionary pressure on early human populations.
How does a disease shape evolution so directly?
Through brutal natural selection. In regions of Africa where malaria was endemic, the mortality rate, especially among children, was devastating. This forced populations to migrate away from high-risk wetland environments, fundamentally altering the demographic map. Furthermore, it drove genetic adaptations.
Like what kind of adaptation?
The most famous example is the sickle cell trait. If you inherit 2 copies of the sickle cell gene, you suffer from sickle cell anemia, which is a severe and often fatal disease. But if you inherit just 1 copy, it alters your red blood cells just enough to provide significant resistance to the malaria parasite without causing full-blown anemia.
Oh, wow. So having 1 copy became a survival advantage.
Exactly. The evolutionary pressure of malaria was so intense that it allowed a deleterious, dangerous gene to flourish in the population simply because surviving malaria to reproductive age was the overriding biological imperative.
The parasite actively sculpted our genome.
It left a permanent mark on our DNA.
The microscopic world rewriting human DNA. And, while that mechanical volcano in Melbourne is a safe, controlled way to view Earth's power, the real planet is incredibly dangerous and currently undergoing massive shifts.
The geology is waking up.
It feels like it. Which brings us to the systems governing our planet right now. Geologists are sounding an urgent alarm about a, quote-unquote, double West Coast earthquake threat in North America.
This is a major concern for emergency planners.
So recent geological core sampling suggests that the Cascadia subduction zone, which runs off the coast of Oregon and Washington State in the U.S., and the famous San Andreas Fault in California might be fundamentally linked.
Connected fault lines.
Yeah. A slip in one could trigger a rupture in the other within minutes or even hours. 50 million people live in this combined vicinity. Now, disaster movies have conditioned us to always expect the big one.
Right, the Hollywood version.
Is this double threat an actual historical precedent, or is it just a computer-modeled worst-case scenario?
Disaster fatigue is a real psychological barrier to preparedness, but the scientific evidence here is empirical. It's happened before.
How do they know that?
Geologists look at the sediment layers on the ocean floor and in coastal marshes. When a massive earthquake strikes, it triggers underwater landslides called turbidity currents, which leave distinct, datable layers of sediment.
Like tree rings, but for earthquakes.
Exactly. By analyzing these layers up and down the coast, scientists found that massive megathrust earthquakes on the Cascadia Fault, like the famous 1700 quake that sent an orphan tsunami all the way to Japan, frequently perfectly align in time with major ruptures on the northern San Andreas Fault.
So it's not a coincidence, it's a chain reaction.
Precisely. The Cascadia subduction zone is where the Juan de Fuca tectonic plate is shoving itself underneath the North American plate. It gets stuck, building up immense stress over centuries.
And when it finally snaps,
It produces a magnitude 9.0 earthquake. The sheer mechanical force of that rupture transfers stress through the continental crust southward. If the San Andreas Fault is already loaded and near its breaking point, that sudden transfer of stress from Cascadia acts as the trigger, causing it to snap almost immediately.
okay, what does that mean for how we prepare? Because that sounds apocalyptic.
It means our current emergency management frameworks are dangerously compartmentalized. The U.S. Federal Emergency Management Agency and state governments, they typically prepare for regional disasters.
Right.
California runs drills for San Andreas. The Pacific Northwest prepares for Cascadia. If they rupture simultaneously, the emergency infrastructure, medical supply chains, and power grids across the entire western seaboard of North America would be crippled at the exact same moment.
So no one could help anyone else.
Exactly. Mutual aid agreements between states would collapse because no one would have resources to spare. The preparation must shift to an unprecedented continental scale.
And the planet isn't just shaking. The weather and geological systems are highly volatile globally right now.
We are seeing extreme events everywhere.
The Mayon volcano in the Philippines, which is one of the most active in the world, just erupted, hitting a level 3 alert and forcing emergency evacuations across 52 surrounding villages.
A very dangerous situation there.
Meanwhile, in Kenya, deadly floods and massive landslides have caused significant casualties, marking the second major flooding disaster the country has faced in just months.
The Mayon eruption is a visceral reminder of the realities of populations living on the Pacific Ring of Fire. But the compounding disasters in Kenya, along with severe flooding events recently seen in Angola and South Africa, point to a broader disruption.
A disruption of what?
The hydrological cycle of the planet is becoming weaponized by the accelerating climate reality.
And the data on the climate reality is just staggering. According to a new comprehensive report, ice melt in Greenland has surged sixfold since the 1990s.
Sixfold is an incredible acceleration.
We went from losing 12.7 gigatons of ice per decade to 82.4 gigatons per decade. Scientists state this is the fastest rate of melting in the last 12,000 years.
To put a gigaton in perspective, because it's hard to visualize,
Yeah, please do.
1 gigaton of ice is a block covering 1 square kilometer standing kilometer high.
Right.
Greenland is shedding 82 of those per decade into the ocean. This isn't just about losing frozen landscapes. It is the primary driver of global sea level rise. Furthermore, pouring that much cold, fresh water into the North Atlantic actively disrupts the Atlantic meridional overturning circulation.
That's the ocean current system, right?
Yes, the deep ocean currents that regulate global weather patterns. Disrupting that leads to exactly the kind of extreme weather events we are seeing in places like Kenya.
And if the ice melt wasn't terrifying enough, researchers have identified a completely new contributor to global warming: microplastics.
This is a shocking paper to read.
Specifically, the massive concentrations of plastic waste swirling in ocean gyres like the Great Pacific Garbage Patch are now actively absorbing and scattering sunlight, essentially trapping heat in the water.
It is a profound and tragic irony. For decades, the narrative around plastic pollution has been strictly ecological.
Like the horror of sea turtles caught in six-pack rings or fish ingesting toxic polymers.
Right. We viewed it as a biological poison. But this research proves it is also a thermodynamic agent.
How does plastic actually trap heat, though?
Well, as millions of tons of plastic break down under UV light and wave action into microscopic particles, they form a sort of soup in the upper layers of the ocean. Normally, water absorbs a certain spectrum of solar radiation and reflects the rest.
Okay.
But these microplastics act like billions of tiny mirrors and sponges. They scatter the light within the water column, preventing it from reflecting back into space, and they absorb the infrared heat, transferring it directly to the surrounding water.
So the pollution we pumped into the ocean is literally acting as a thermal blanket.
A thermal blanket warming the very waters that are accelerating the melting of the Greenland ice sheet. It is a devastating feedback loop.
Is there any viable technology to stop this loop? Because that sounds incredibly bleak.
There is a significant breakthrough in green chemistry, reported this week, actually.
Yeah.
Scientists have developed a process using sunlight to turn plastic waste into clean hydrogen fuel.
Really? How does that work?
It uses a method called solar-driven photoforming, utilizing photocatalysts wrapped in hydrogel polymers.
Okay, break down the chemistry for me. How does a hydrogel turn a plastic bottle into fuel?
Plastic is essentially a long chain of carbon and hydrogen atoms, tightly bound together. The scientists embed a special chemical catalyst, like a microscopic metal sponge, inside a hydrogel.
And hydrogel is just like a squishy polymer.
Right, a polymer network that holds a massive amount of water. When you place ground-up plastic into this system and expose it to direct sunlight, the catalyst absorbs the solar energy and uses it to break the molecular bonds of the plastic.
It just tears it apart.
It violently tears the carbon and hydrogen apart. The hydrogen is released as a clean gas, which can be captured and used in fuel cells to generate electricity with zero emissions, while the remaining carbon is broken down into less harmful organic chemicals.
That sounds like the ultimate solution, taking a toxic pollutant and using free solar energy to turn it into green power.
The chemistry is elegant, it's revolutionary,
Yeah.
but the bottleneck is industrial scaling.
Because there's so much plastic.
Exactly. Humanity dumps approximately 8 million tons of plastic into the oceans every single year. Taking a brilliant photoforming process that works in a laboratory beaker and scaling it up to massive floating ocean refineries, capable of processing millions of tons of degraded microplastics.
That's a huge leap.
It is an engineering and economic hurdle of monumental proportions. It proves the science is possible, but the logistics remain entirely daunting.
Which brings us from the massive scale of planetary survival and global logistics down to the most intimate scale possible, the individual.
The biology.
Yeah. Our final section today explores the human machine. How does the human body and mind cope with disease, our changing environment, and the ravages of aging? Let's start with a massive leap at the edge of medical science. Researchers have announced that humans may be able to regrow missing teeth within 4 years.
This is a radical departure from traditional dentistry. They are utilizing stem cells, bone morphogenetic proteins, often called BMPs, and white proteins.
I'm just thinking of the sheer relief of never having to get a synthetic implant or a root canal ever again. But how do you actually convince the adult jaw to just grow a new tooth?
It is a masterclass in biological signaling. We all have stem cells in our dental pulp and jaw cells that have the potential to become different types of tissue.
Yeah.
But they sit dormant.
Right.
When we are embryos, specific proteins act as chemical messengers, telling those stem cells to differentiate into enamel, dentin, and root structures. The BMPs and want proteins are those exact messengers.
So they just reintroduce them.
Scientists have figured out how to synthesize and precisely deliver these proteins to the site of a missing tooth in an adult. The proteins bind to the receptors on the dormant stem cells, effectively turning the genetic switch back on.
It tricks the adult body into thinking it's growing an infant tooth?
It initiates the embryonic tooth development pathway, growing a complete biologically natural tooth from scratch.
That is just incredible. And it's not just the physical structures like teeth. We are making breakthroughs in maintaining the brain itself. A new neurological study proves that physical movement triggers a literal cleaning effect in the brain.
This is fascinating research.
Furthermore, researchers found that boosting a specific protein called SOX9 enhances astrocytes, allowing the brain to actively fight off Alzheimer's disease.
This research beautifully connects lifestyle choices to molecular neurology. The brain doesn't have a lymphatic system to clear out waste like the rest of the body does.
So how does it clean itself?
It relies on the glymphatic system, where cerebrospinal fluid washes through the brain tissue to clear out toxic byproducts, like the amyloid beta plaques that accumulate and cause Alzheimer's.
And exercise acts as a pump for that fluid.
Exactly. The physical mechanics of movement and the increased cardiovascular blood flow literally pump the cerebrospinal fluid through the brain more efficiently.
That's the mechanical part, but what about the protein you mentioned, SOX9?
The second part of the study is even more crucial. Astrocytes are star-shaped glial cells that manage the brain's housekeeping. When plaques build up, astrocytes try to clear them, but in Alzheimer's, they get overwhelmed and become dysfunctional.
So boosting SOX9 helps them out.
The researchers discovered that by boosting the SOX9 protein, they could supercharge the astrocytes. It restores their ability to engulf and break down the toxic plaques. It represents a shift from trying to invent drugs that dissolve the plaques to empowering the brain's innate cellular immune system to clean itself.
It's an incredible defense mechanism, but while we are learning to empower our immune systems inside, the environment around us is actively fighting back.
Yes, the vector map is changing.
Medical reports show that emergency room visits for tick bites and the resulting cases of Lyme disease are skyrocketing across the U.S. Northeast and the Midwest, particularly in the state of Wisconsin. Simultaneously, global health monitors are tracking the spread of dangerous free-living amoebae, or FLA.
This ties directly back to our earlier discussion on climate modeling. A warming planet doesn't just melt ice, it radically redraws the biological map.
How so for ticks?
Ticks are surviving longer into the autumn and emerging earlier in the spring due to milder winters. Their geographic range is expanding rapidly into areas where public health infrastructure isn't accustomed to dealing with Lyme disease.
And the amoebae. These are the organisms responsible for those incredibly rare but usually fatal brain infections, right?
Yes. Free-living amoebae thrive in warm, stagnant freshwater. Historically, they were a risk isolated to naturally warm southern lakes during peak summer heat waves.
So they are moving north.
As average global temperatures rise, lakes and rivers further north are reaching the thermal threshold to incubate them. More alarmingly, aging urban water infrastructure pipes that sit near the surface and absorb ambient heat are becoming breeding grounds. Climate change is physically moving pathogens into contact with human populations that have no historical exposure or immunity.
It really highlights just how profoundly fragile our biology is when the environment shifts even slightly.
It does.
And I want to close today's deep dive by looking at two specific human stories that perfectly encapsulate that physical fragility, contrasted against the absolute brilliance and durability of the human mind.
These are two very powerful stories.
The first is a tragic event the media referred to as the ghost plane incident. In June 2023, a Cessna 560 Citation V business jet flew completely unresponsive through highly restricted airspace over Washington, D.C. in the United States.
It triggered a massive security response.
It caused the military to scramble F-16 fighter jets, which broke the sound barrier over the city trying to intercept it. The plane eventually ran out of fuel and crashed over Virginia. The investigation concluded the cause was pilot hypoxia, a total lack of oxygen due to a failure in cabin pressurization.
Hypoxia is an insidious killer. Above 10,000 feet, the atmospheric pressure is simply too low to force enough oxygen into your bloodstream.
But wouldn't the pilot notice they were suffocating?
If an aircraft depressurizes gradually, the pilot doesn't choke or gasp for air like you would underwater. Instead, the brain is slowly starved of oxygen. It triggers confusion, a false sense of euphoria, and the rapid degradation of cognitive ability and motor skills.
So you just don't realize you're in danger.
The brain, attempting to survive, shuts down the prefrontal cortex, which is the area responsible for complex problem-solving and situational awareness. Within minutes, a highly trained, experienced pilot becomes entirely incapable of recognizing the danger, communicating on the radio, or flying the plane. A slight drop in air pressure dismantled a human mind.
The physical environment just turns the mind off. But contrast that absolute vulnerability with the second story from a medical facility in Lebanon, Tennessee, in the United States.
This story is unbelievable.
An elderly husband and wife, both suffering from severe dementia, were living in a locked, secure memory care unit. The husband, a veteran with a deep military background, managed to orchestrate an escape with his wife.
And he didn't use force.
No, he didn't break the door down. He listened. He listened to the medical staff continually punching the electronic keypad to open the door. Utilizing his deeply ingrained, decades-old military training in Morse code, he translated the varied auditory tones of the keypad beeps into their numeric equivalents.
He reverse engineered it.
He reverse engineered the digital lock purely by sound, typed in the code, and walked right out the door with his wife.
It is an utterly astonishing juxtaposition of neurological reality.
It's breathtaking. In the ghost plane, a perfectly healthy, highly trained brain is instantly undone by a lack of an invisible gas. But in that memory care unit, a brain physically ravaged by dementia, a disease actively destroying neural connections, still possessed this incredible, complex auditory processing and pattern recognition capability.
It reveals the profound architecture of human memory. Dementia ruthlessly attacks the hippocampus, destroying short-term memory and executive function. The patient might not remember what they had for breakfast or where they are.
But the code was still there.
Because procedural memory, deeply ingrained skills, habits, and patterns, learned through intense repetition over a lifetime, like military Morse code training, is stored in entirely different, older neural pathways, like the basal ganglia and cerebellum.
So the disease just couldn't reach it.
The cognitive reasoning was failing, but the core essence of his training, the sheer intellectual capacity to decode an auditory cipher, remained completely intact and functional. It bypassed the disease entirely.
Wow. We have covered a vast terrain today. We started with physicists charting microscopic flaws in the flow of time and chemists mapping the hidden liquid states of water with lasers.
We covered a lot of ground.
We watched an AI hunt for exoplanets in the Neptunian desert and explored the stellar cannibalism of white dwarfs. We navigated the explosive geopolitics of the Strait of Hormuz, the physical land grab for AI data centers, and unearthed Viking silver tracing trade routes 1,000 years old.
And we looked at the Earth itself shifting.
Right, the shifting fault lines of our planet and the incredible resilience of a human mind using Morse code to escape a locked room.
If there's a final thought to leave you with, it's a reflection on exactly what you, the listener, are. We are biological machines. We are fragile enough to be undone by a microscopic amoeba thriving in a warm pipe or a simple drop in cabin pressure at altitude.
So fragile.
Yet, housed within that fragile biology is an intellect capable of mapping the quantum flaws of time, building artificial brains, deciphering the climate history in Greenland's ancient ice, and peering back into the ravenous star factories at the very dawn of the universe. The incredible dichotomy between our physical vulnerability on this planet and the boundless capacity of our intellect is the defining characteristic of the human experience.
It really brings us right back to the beginning. The universe is murky, it's complex, and actively rewriting its own rules, but we keep building the tools to map it, and we keep looking. Thank you so much for joining us on this deep dive. Keep looking up at the stars, keep looking down at the ground beneath your feet, and never stop questioning the reality around you. We'll catch you next time.
Enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
Welcome to the debate. Imagine for a moment that you are tasked with rewiring the electrical grid of an entire house. But, you have to do it while the power is still on.
Right. And the residents are living in every single room.
Exactly. And that is, that's precisely what we are witnessing on a planetary scale today, May 4th, 2026. We're watching the arteries of global energy, trade, and technology being fundamentally rewired in real time. And to really grasp what's happening here, we have to elevate our view from just a single national lens to a truly planetary perspective. The world isn't just America or Europe. It's a deeply interconnected grid.
And today we're pulling from some incredibly varied reporting across the globe, from Reuters and Al Jazeera to DW, the BBC, TechCrunch, and the Washington Post, really trying to understand this rewiring. Because the central question we are looking at today is whether these massive geopolitical disruptions are, actually beneficial. Like, are militarized trade routes, protectionist tariffs, and these fractured tech alliances acting as necessary catalysts? Are they forcing the globe toward a more decentralized, resilient multipolar economy? Or, and this is my view, do they represent a catastrophic descent into zero-sum mercantilism and global fragmentation?
Right. And I argue that what we are seeing, this aggressive dismantling of outdated alliances and the enforced security of the global commons, it is actively building a decentralized, highly resilient planetary market.
And I argue the exact opposite, weaponizing trade routes, slapping punitive tariffs on allies, and splintering critical AI infrastructure. It's driving the global economy toward a volatile and frankly dangerous fragmentation.
Well, let's lay out the framework here. If you look at the traditional hyper-centralized global order of the late 20th and early 21st centuries, it was arguably a system artificially propped up by a single hegemon.
Sure.
What we are experiencing now is a necessary market correction on a geopolitical scale. Think about the UAE's historic decision to exit OPEC. That is evidence of healthy decentralization. Countries are bypassing bloated cartels to prioritize direct, efficient trade corridors, like the new routes opening between the Gulf and South Korea.
But at what cost?
Well, if you're listening to this, then looking at your 401k, you might be wondering why the S&P 500 just hit a record high to kick off May trading, while the world seems so chaotic. The reason is that the global financial system is demonstrating incredible resilience. Even things like the U.S. implementing a 25% tariff on EU cars, that shouldn't be viewed as chaos. It's a necessary recalibration of fair trade, forcing allies to share the defense burden.
Okay, but what you are describing as resilience is in practice extortion. It's a zero-sum nationalism that punishes innocent global citizens. We are watching the active weaponization of the planetary economy.
I wouldn't call it weaponization.
You mentioned the markets hitting record highs, but let's look at the actual physical world for a second. Look at Dubai. Its status as a stable, global financial hub is facing its biggest test in history precisely because of this engineered instability. A 25% tariff on European automakers and the withdrawal of thousands of American troops from Germany, that doesn't recalibrate fair trade. It actively dismantles the cooperative frameworks that have kept the planetary economy stable for decades.
I have to push back on that.
We are witnessing the construction of a new Iron Curtain, right? One built on economic blockades, weaponized technology, and military brinksmanship that ultimately it drives up costs for global consumers, especially in the developing world.
Well, if we are going to talk about the physical world and economic blockades, we absolutely have to talk about the Persian Gulf, because right now, military force and diplomacy are colliding over the actual physical arteries of global trade. The Strait of Hormuz is the quintessential choke point, and it's currently under a severe blockade.
Exactly. And the way that choke point is being handled, it exposes the exact problem with this so-called resilient multipolar shift. I want to focus on Iran's 14-point peace proposal, which was submitted recently through Pakistani mediators.
The extortion proposal, you mean?
This plan explicitly offered an off-ramp, a way to reopen shipping and establish a permanent governing mechanism for the strait. And what happened? The U.S. rejected it completely, in favor of deploying 15,000 troops under Project Freedom and threatening to sanction neutral shipping companies if they pay Iranian transit tolls. I'm sorry, but I just don't buy that. Let me tell you why. Holding 20% of the world's seaborne oil hostage to a military standoff is just reckless.
Reckless how exactly?
Because of the mechanism of the sanctions themselves. When the U.S. threatens international shipping firms with total excommunication from the Western financial system, it causes freight rates for basic aid shipments to swell by 18%, according to recent UN reports.
Yeah, short-term friction.
It's not just friction. It completely disrupts supply chains to Latin America, to Africa, to Asia. You are essentially punishing neutral nations and global consumers who just need energy to power their grids. It is the definition of putting national pride above planetary stability.
Yeah, I'm not convinced by that line of reasoning, because honestly, it ignores the fundamental mechanics of extortion. Iran's 14-point proposal wasn't some good-faith diplomatic effort. It was a demand for protection money.
That's one interpretation.
They were asking the world to legitimize their right to choke off a global artery unless their specific political demands were met. Let's break down the mechanism here. If the world steps back and allows a single regional actor to charge arbitrary tolls on a planetary energy artery, aren't we just inviting a localized monopoly that will inevitably crash the global economy? The U.S. naval presence, Project Freedom, is acting like a municipal police force, keeping a vital public highway open for everyone.
But a police force doesn't usually threaten to bankrupt the civilians it claims to be protecting. It's a unilateral military deployment setting up a rival toll booth made of economic sanctions.
No, it's enforcing freedom of navigation.
If a shipping firm from, say, Brazil or India calculates that paying a physical toll to Iran is the safest, most economically viable way to get their cargo to their home ports, the U.S. stepping in and saying, "We will sanction you," forces those neutral countries to choose between the physical safety of their vessels and the economic survival of their companies. That doesn't create resilience. It creates a paralyzed global energy market.
That's an interesting point, though I would frame it very differently. The short-term friction of these sanctions,
the delays, the spikes in freight rates you mentioned, that is the price of long-term structural integrity.
A steep price.
If you allow the precedent that any nation bordering a maritime choke point can suddenly demand tolls under the threat of military force, you completely unravel the entire concept of freedom of navigation. The pain we are seeing now in the shipping insurance markets, it's like the planetary immune system fighting off a localized infection of maritime extortion. And remarkably, the markets understand this.
Do they?
Yes. That is exactly why the S&P 500 is hitting record highs. The market is pricing in the fact that this enforced security will ultimately preserve the integrity of global trade.
You call the U.S. Navy a police force protecting the global order in Hormuz. But how can you claim they're protecting the global order when in the exact same breath, Washington is slapping 25% tariffs on its own European allies and pulling 5,000 troops out of Germany?
Well,
that's not a police force acting for the global good. And it leads us perfectly into how these actions are actively fracturing traditional alliances. We are seeing a massive pivot as instability in the Middle East forces nations across Europe and Asia to hedge their bets against this exact unpredictability.
I actually view this shift as incredibly positive. You bring up the tariffs and the Gulf. Let's look at what is actually happening there. The UAE has exited OPEC.
Right.
This isn't just a political statement. It fundamentally alters the pricing mechanism of global energy. Instead of a centralized cartel artificially choking supply to dictate global prices, the UAE and Qatar are establishing new, direct Gulf-Asia trade corridors with South Korea. You now have a direct peer-to-peer economic circuit. If a shock hits the global system, that bilateral circuit can adjust its own flow without waiting for a consensus from a dozen other nations. At the same time, applying pressure on Europe with the 25% auto tariff and troop withdrawals, it successfully forces Europe to finally fund its own defense.
Wait. Successfully forces? We are talking about a punitive tax on European economies that are still navigating recovery from successive global shocks.
Yes, exactly. Because it forces them to grow localized economic muscle. Isn't it fundamentally healthier for the global economy if regions like Europe and the Gulf build their own sovereign defense and trade capacities rather than relying on a unipolar security umbrella that is clearly no longer sustainable? We are watching the birth of a multinodal planetary economy.
That is a highly sanitized way of describing massive economic destruction. I mean, German politicians are outright warning about the financial burden of these rifts, comparing the economic drag to the costs of previous wars. And regarding the Gulf states, you talk about these peer-to-peer circuits as if they are born out of visionary strength. They are doing it out of panic.
Panic?
Yes, the traditional security guarantees of the West are evaporating. I mean, let's ground this. The UAE is literally installing next-generation Israeli iron beam laser defense systems on its soil to protect its airspace, while simultaneously signing massive trade deals with Beijing and Seoul.
Which is diversification.
That is a schizophrenic security posture because they don't trust anyone. This doesn't build a multinodal utopia. It builds a fragmented, highly paranoid system where every region has to duplicate supply chains, duplicate military spending, and pass those massive inefficiencies on to the global consumer.
But those inefficiencies, as you call them, are actually redundancies. And in systems theory, redundancy is the core of resilience. Yes, duplicating supply chains cost capital in the short term. But when a single shock, like a blockade in the Strait of Hormuz, can threaten 20% of the world's oil, you absolutely want the UAE building alternative trade corridors to South Korea.
I'm not saying it doesn't make sense for them, but
You want Germany realizing it must rebuild its defense industrial base rather than outsourcing it. The unipolar model was efficient. Sure, highly optimized for profit. But it was incredibly fragile. By introducing these tariffs, the U.S. is essentially stress testing the planetary economy.
that's a compelling argument. But have you considered what happens when that stress testing logic is applied to the fundamental building blocks of our future? I want to move from physical trade routes to the digital realm. Let's look at the weaponization of artificial intelligence.
Okay, I think this is where the market dynamics become truly fascinating.
Fascinating maybe, but deeply concerning. Look at the Pentagon's recent moves. They just signed massive agreements with top AI companies, NVIDIA, Microsoft, Amazon, SpaceX, to develop classified networks for military operations. but they explicitly excluded Anthropic, citing supply chain risks.
Hold on. I want to make sure I understand your objection here. The military chose certain vendors over others for classified data. How is that different from any normal defense contracting?
Because of the scale and the intent. What we are seeing is the state attempting to militarize foundational AI and create government-sanctioned tech monopolies. By walling off certain companies and locking others into the military-industrial complex, you are threatening global interoperability. You are splintering the digital commons.
I don't see it as splintering.
Look at how the rest of the world reacts. The European Union's reaction to this American tech nationalism is to propose a multi-billion-euro AI gigafactory plan to achieve what they call computing sovereignty.
Which, again, creates redundancy.
No, it creates a walled garden. If the EU is trying to build a sovereign data center, but they still have to rely on advanced chips designed in the US or fabricated in Taiwan, they aren't achieving sovereignty. They are just hard-coding geopolitical fragmentation into the algorithms that will eventually run global finance, healthcare, and logistics. Every major geopolitical bloc is trying to build its own silo.
I see why you think that, but let me give you a different perspective on how the global flow of capital is actively overriding that state-level fragmentation. You are entirely right that the Pentagon excluded Anthropic. They tried to build a silo. But what happened next?
Wall Street stepped in.
Exactly. The state didn't kill the company. Instead, Wall Street immediately stepped in. Goldman Sachs and Blackstone are nearing a $1.5 billion joint venture with Anthropic. At the exact same time, OpenAI is launching a $10 billion joint venture with private equity giants TPG and Bain Capital to provide enterprise AI services.
And you see that as a positive mechanism?
I see it as capital functioning like water, in a physical ecosystem. The Pentagon tried to build a dam by locking Anthropic out of defense contracts, but capital always finds the path of least resistance. When the military dam went up, a $1.5 billion river of private equity from Blackstone immediately flowed around it.
Wow.
Right? Creating commercial APIs that diffuse that technology globally anyway. Doesn't the fact that private capital can step in to fund and distribute an AI firm deemed too risky by the military prove that our decentralized economic system is highly resilient? The state doesn't dictate innovation anymore. The global market does.
But the global market isn't a neutral, benevolent force. When Wall Street firms like Blackstone and Goldman Sachs step in to fund Anthropic, they aren't doing it to ensure open, democratic access to AI across the planet. They are doing it to capture enterprise value. You're simply trading state monopolization for private equity monopolization.
But private equity has an incentive to scale globally. A Defense Department has an incentive to hide the tech.
Even if they scale to the highest bidder. When you combine private equity monopolization with the EU's push for a sovereign AI gigafactory, you end up with a fractured global landscape that completely leaves out the developing world.
How so?
If AI development requires hundreds of billions in infrastructure investment, which is driving up the cost of chips and energy globally, by the way, how does a startup in Latin America or Africa compete? They don't. The fragmentation remains. It just shifts from military exclusion to financial exclusion.
That assumes that the innovations funded by this private equity won't diffuse globally, which historically they always do. The massive capital injection into Anthropic and OpenAI ensures that these models will be scaled rapidly, lowering the cost of compute over time. By partnering with private equity, these AI firms can deploy their services to thousands of portfolio companies worldwide instantly, transcending national borders.
But at what cost to the end user?
Well, just like the UAE exiting OPEC to trade directly with South Korea, we are seeing tech companies bypassing traditional government grants to build direct global commercial networks. The friction, whether it's the Pentagon's exclusion or the EU's defensive gigafactory, is simply the market figuring out how to properly price risk.
Risk that is being artificially manufactured by aggressive state policies. You cannot separate the physical and the digital here. The energy required to run these massive AI data centers, like the ones private equity is buying up land for right now, is intrinsically linked to the global energy markets that are currently being choked off in the Strait of Hormuz.
They are connected, yes.
Deeply connected. When the U.S. slaps a 25% tariff on European cars, strains its alliance with Germany, and then tries to monopolize the top AI firms for its military, it sends a clear signal to the rest of the planet. You are on your own. That doesn't result in a beautifully decentralized web of sovereign trade. It results in a frantic arms race for energy, chips, and military security. It's an environment where trust is zero, and every transaction is viewed through a lens of national security.
Trust may be low, but reliance on mutual economic survival remains high. That is the essence of a realist, multipolar world. The unipolar system relied on trust in a single superpower, and it made the whole planet vulnerable to that superpower's missteps. The new planetary economy relies on the undeniable math of mutual benefit.
Undeniable math?
Yes. When Qatar and the UAE build a trade corridor to Asia, they don't need to trust Seoul. They just need to align their economic circuits. When Wall Street funds Anthropic, they are aligning capital with technological inevitability, regardless of what the Pentagon thinks.
But we have to look at the human and systemic cost of this transition. You call it the undeniable math of mutual benefit, but the math right now is highly destructive. Inflation is climbing. Aid shipments to the global south are delayed. And the UN is warning of severe humanitarian challenges because fuel costs have skyrocketed due to the Hormuz blockade.
Transitions are messy.
The cost of a 25% tariff on European goods is paid by everyday consumers who are just trying to afford a vehicle. The fragmentation of AI means competing incompatible standards that stifle global scientific collaboration. Yes, capital will always route around political roadblocks, like water flowing around a dam, like you said. But the friction generated by those roadblocks causes immense collateral damage downstream.
Well, I think it is time to draw our final thoughts together. Throughout this discussion, I have maintained that the planetary economy is successfully, albeit painfully, shedding its outdated, centralized dependencies. The friction we are seeing, whether it is the military standoff in the Strait of Hormuz, the aggressive tariff recalibrations in Europe, or the Pentagon's stringent AI defense contracts, these are not signs of a system collapsing. They are the growing pains of a more robust, multipolar world. We are moving from a fragile single point of failure global order to a decentralized network where risk is distributed. Sovereign trade corridors, like those emerging between the Gulf and Asia, and the massive private capital markets overriding state tech monopolies. They prove that the planetary economy is highly resilient. It is capable of managing its own evolution even under extreme stress.
And my position remains that weaponizing trade and technology is an incredibly dangerous game that we are losing control of, leaving the world vulnerable to sudden, punitive tariffs, militarized choke points in vital energy arteries, and fragmented nationalistic AI ecosystems. It threatens to reverse decades of hard-won global economic integration.
Right.
This isn't a clean transition to resilience. It is a descent into zero-sum mercantilism that risks leaving developing nations in Latin America, Africa, and parts of Asia completely behind. It forces global consumers to pay the ultimate price for great power posturing.
Yet, if there is one point of convergence between us today, it is the mutual recognition that the old, unipolar, Western-centric global order is definitively over.
I definitely agree with you there. The era of a single architect designing the global system has passed. The new planetary economy will undoubtedly be defined by how capital, technology, and human ingenuity route around these new political and military roadblocks.
And understanding that reality requires us to look at these events with intellectual charity, observing them from a truly planetary viewpoint rather than a strictly national one. There is so much more to explore in the shifting sands of this new global reality, from the boardrooms of Wall Street to the waters of the Persian Gulf. We will leave it to you, our listeners, to observe this ongoing global realignment and draw your own conclusions. We began today by imagining the rewiring of a house while the power is still surging through the walls. As the sparks continue to fly across trade routes and data centers, the only question that remains is, when the new grid is finally connected, who will control the switch?
That's it for today's Artificially Informed.
Nope. Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.